Hello everyone and welcome to PentaBAR. This is actually the 19th session this year only. I'm Cornel Fatulescu and I will be your guest today. And if you don't know much about me, don't worry. I will take the next 2 hours to speak about me. But if you don't know about the speakers, that needs to change. Now, before speaking about the speakers, I'd like to speak about the format a bit. Each speaker has 45 minutes, including questions. If you have questions, just write them on the chat. I will watch the panel and ask kindly the speakers to do a break. And this should be all along the way during their presentation. Part of myself as the moderator, you might wonder, why am I moderating this PentaBAR? Because I'm not the usual guest. To be honest, not so many people come to my PentaBAR, so I looked at the talks and I say, oh, these are some sophisticated talks, and there will be some smart audience, so let me jump in. A few words about me. I am Chief Platform Officer at Pentalog. If you want to know more, you can find the details on the site. I'm currently in charge with strategy, product strategy, and technology strategy of the group. I will not talk a lot about the delivered projects, the thousands of them, hundreds of new customers that we have every year, or the 90% renewal year to year that we have. I will only ask you to remember one thing about Pentalog, is that our ambition is to become the largest set of services for our customers to self-serve in their products digitization and services digitization journey. Now, enough about me and Pentalog, because I believe you are eager to meet the speakers. So one thing that might be interesting for you to know, hope that I can, before jumping to the speakers, you might want to look after this session of the technology trends. You find them on our site. Very interesting, great content for you to explore. And let me go further to present you Alex. Alex, who is a very important contributor in the JavaScript community, as you've already seen. It's not his first PentaBAR. It's honestly, the human side of accessibility is one of my favorite PentaBARs. And I do feel Alex is helping the tech community to move forward in many regards. But I believe it's better for him to present himself and tell us a bit more about your talk, Alex.
Sure. Not sure if my video is on. I guess so.
I can see you.
Okay. Should I start sharing my screen?
Please.
Okay. Let's see. Okay, I think we're good. So yeah, thank you for the for the introduction. Good morning, good afternoon, wherever you are. Sorry, my voice is a bit rusty. It's been more than 6 months now since I did my last talk, so probably that's why it will take a bit to get into speed. Thank you very much for joining this session. I'm going to take hopefully the next 35-40 minutes to walk through some of my thoughts on React hooks. So yeah, just as a quick recap, as mentioned before, my name is Alex. I work at Code Sandbox. I'm also one of the organizers of JS Heroes, one of the biggest JavaScript communities in Romania. And you can find me on Twitter at Alex Moldovan. And also very important, if you want to get any information from the slides, you can find them on this URL, which I'll also paste at the end of the talk in the chat. So the URL is public. You can have access to the slides. There aren't a lot of relevant links, but maybe just pieces of information that you want to check out later. So we're going to talk about hooks a bit, and I don't want to make this so this won't be like a introductory talk to React hooks, but I won't go into very technical or complex subjects. More like I want to present kind of my personal experience with hooks, how I had this kind of relationship of not carrying them, hating a bit some of the parts, and then loving it, and like how I ended up with how I work today with hooks. So let's see. Yeah, back in 2018, the React team introduced hooks as a new way, a new syntax to write. To bring more functionality to function components in React. Before that, you had to choose between making a class component or a function component. And at the first, originally, a lot of people in the community were super happy about this change. A lot of other people were not that happy because the React community was already going through a lot of changes in the past years or so. And some people were like, oh no, I need to learn a new thing now. But some other people were on the other side really happy because they had these new functions that seemed that could solve their problems and make their components, a bit maybe slimmer or easier to understand. I started working with React back in 2014, so that was quite a while ago. So I've seen a lot of changes in the framework across the years, and I've seen a lot of patterns becoming best practices and then worst practices and then best practices again and so on. So when hooks originally were announced, I was like, okay, it sounds good. This looks interesting. I like that you can do it. I'm a bit skeptical about the whole magic thing of how they work, but I will take it. And then started working with hooks in various teams and on various projects. And the original understanding, and this is kind of the point from which I kind of took it, I kind of took a wrong turn, as well as a lot of other people in the community. We were kind of looking at hooks as another way of doing the same patterns, right? Just a different syntax for expressing the same things as before. So like we had the component did mount lifecycle method, we now use the use effect, component will unmount, be the return, and so on. So like you've seen this table all over, like how everyone was kind of jumping to hooks and then asking like, how do I implement the things that I previously know from React? Like the way in which I knew before how to create class components with lifecycle method in this case, or with state and so on. And then things got slowly harder and harder. And by the way, in case you missed it, there's an emoji here at the bottom of the screen that kind of signals my relationship with hooks as this timeline progresses. So like keep an eye on what my state was during the time. Then it got like, we started working more and more with hooks, right? And there were rules of hooks that you had to obey. And then I started realizing that you need to adapt to new patterns. Like just a random example. Now use effect is a synchronous nature, and there were patterns before where you would use async calls in component did mount. So you had to have a different way for that. And then functions started piling up because everyone was jumping on the hooks train and everyone wanted to convert all their components into hooks. And it just ended up with a bunch of functions written inside functions. and a lot of callback functions. And in a lot of projects that I've seen, things got a little out of hand, and especially with the last part, which is the list of dependencies. At this point, that's the last argument for use effect or use callback. And this is where things, first of all, people are misusing that very often, putting their object references, arrays, functions, stuff like that. And then also there was pretty much the very possibility of making a mistake just by not updating that list of dependencies when you needed to add a new prop, let's say, to a component. And that's when I realized that maybe I'm not looking at hooks at the right way. And after a couple of conversations with some people, there was something that struck me. Like, I just went back to like, okay, what happens once you have some very basic hooks in the component? And I realized that the mindset is actually that hooks give you a separation of concerns. And this is kind of the if you want, the key takeaway from this whole thing that I'm blabbing about. When you look at the hook, and I'm taking this image from, when you look at the function component with some hooks, I'm taking this from the React docs. The thing that actually got me more and more into hooks was when I realized that this part here is imperative code, and this part here is declarative code. So just a quick, not to use fancy terms here. So like in imperative programming, you tell the program what it should do, right? It's you're writing directly the instructions, whereas in declarative programming, you're just telling what it needs to be the result. Like, you want these things to render. You don't care about how the program does that. And if you think about it, in this example, which is a very silly example maybe, but you're actually doing the same thing, right? At the end of the day, when this gets rendered to the screen, it's still some sort of DOM operation. But in the hook, you do it imperatively. You say document.title equals something, whereas React, the JSX part of React is highly declarative. And you will just give the form, like the structure of what you want to render, and React will make sure that those nodes are rendered. So let's look at some code quickly. I wanted to, and by the way, this screen will always be like a queue for jumping into Code Sandbox to test something out. So I wanted to implement something a bit more complex than the counter. So I ended up with a counter that counts itself, right? It has an automatic set interval. Every second, this timer component, if you want, will update. So if I mount this component in here, it will start counting, right? Every second, it will increment this internal state that it has. And it also has a descending flag if you want to count down. But yeah, nothing too complex. And again, I want to highlight here that in this part, in the hook, we are doing it imperatively, right? We are manually setting up this interval at every callback of the interval. We are imperatively setting the state, saying, okay, the state now becomes +1, -1 based on the previous state. Whereas here, even if we do some computation, but this is still pretty much declarative. You're just going and saying, okay, these are the, this is the format of the thing. These are the conditional renders that need to happen. And I just want the DOM to show in the end, like the timer here in seconds, minutes, hours. Yeah, so this also works. Of course, multiple components, everyone has their own thing. Yeah, you get the point. So coming back to this, and I will come back actually and change this in a second. But the most relevant thing here is, again, declarative code, imperative code, right? But we can also, not to use necessarily like programming paradigms and these kind of fancy terms, let's call it logic and view. And what I mean by this is logic as in not necessarily, don't think of business logic, don't think of data handling and stuff like that, which you would normally do in a medium, large size application in some state management. but logic of interaction, right? Interaction with the UI components, interaction between the components, and all sorts of things. So if we consider that now with hooks, we have these two areas of the component very well separated, we can look at the component like this, right? It's part logic, part view. And your application looks like this, right? It's a huge hierarchy of part logic, part view. And in some cases, we were actually used to having these kind of specialized layers, if you want, right? I guess everyone can relate to this, as in, dumb components versus smart components, or presentational container, whatever the names were that you are using. You had one layer of component which would have more logic and just a bit of UI, and then some other layer with more, just very small, maybe logic layer, and just a lot of UI. And the problem was that it's still React components. You still have, even if you look at the dev tools, if you look at your hierarchy of components, it still feels like it's complicated because everything is a React component. And this is what hooks actually give you, but not just hooks, but the most interesting part of hooks, which is kind of my main point from here on, which is custom hooks. So actually, I kind of skipped the whole thing of custom hooks when hooks originally appeared, and I'm not sure how many people jumped on custom hooks immediately, but I think these are super powerful because they actually allow you to extract this logic, this unit of logic that we just isolated with hooks. We isolated in the component, and then custom hooks allows you to extract that logic into a separate file, into a reusable, I call it, unit of logic. So very quickly, not here, let's see what a custom hook is. So I'm going to update this example with the timer, and I'm going to create a use timer hook. And this hook will be a simple function. And I will just try to paste this logic of computing the ticks, right? This is my unit of logic in this component. This is my my imperative code. I'm going to try to copy it out. And then I'm going to need the two hooks actually from React. We can take them from here. And now this hook, the logic in this hook depends on this descending flag that is a prop of the component. So when you have that situation, you normally use the parameters of the hook. So like, let's consider that the descending flag is also a parameter here. And now, because this hook actually exposes a value, its purpose is to compute this value every second, we're going to return this value. And the nice part about custom hooks is they are just JavaScript functions. So you can return arrays, objects, any kind of values. You can pretty much do whatever you want here, as long as you respect the rules of hooks. You use the standard hooks or maybe other custom hooks, and you end up with some result. And you will see later you don't even need to have a result, like a return type for a custom hook. So now we can say ticks is use timer. I know the naming is not right here, but let's hope this works. Okay, so we have the same thing. What we have achieved now is that this function, this hook that gives you a new, gives you an ever incremented or decremented value every second, can now be reused in any other application. So not only the timer component has it, so to say, it doesn't have a strong connection with the timer. Oh, and it needs the flag here to be fully correct. Okay, so what we achieve with custom hooks? Well, if again, coming back to this, and I'm sorry if I'm maybe repeating myself too many times here, but if you consider that the hook is the logic and the JSX function is the view, then instead of this, right, you can pretty much imagine as you take all these logic, units of logic out of your components, and you end up with this. You end up with maybe even fewer React components and a set of hooks that you can combine into these React components. And it works like this, right? A certain React component, let's say, I don't know, a form or something like that, uses some form validation hook. But maybe it also uses some other hook that handles keyboard shortcuts. Maybe you have some global shortcuts in your application that you're managing through some sort of custom hook. But the same hook can also be used in another component. And there, in that component, you add some other hook from some other place. And just to give you an example also of reusability, let's go back to Code Sandbox, and I have another example here. So these are two separate UI components, and one is a model window, which opens something like this in the middle of the screen, and one is a select with dropdown, which will select one of the values from the list. And both of these components, and I'm pretty sure if you work with these components, you had this functionality at some point. You might want, when you click outside of the model window, to close it, right? You know, click, close on click. And the same thing, the drop down, any kind of drop down menu, select whatever you have, will have to also close when you click outside. So you see, I'm clicking here outside. So I'm implementing this with a use effect in both of these components. And I'm listening for the mouse down, event, and then I'm doing a check whether the element that is the reference element, which in this case is the drop-down list here, and in this case is the model container here. So I'm checking if the click is inside the reference element, and if that's the case, this is for the drop-down model. If that's the case, then you return, you don't do anything. Otherwise, you trigger this set state that now if the click was outside of the model is closed. So let's try to extract this into a use click outside hook. And again, it's just a JavaScript function. And inside it, I'm going to copy from the model for now, and then we're going to adapt it for the dropdown as well. Let's copy this. So looking back at the model, you don't want you cannot put the ref inside the hook, because the ref is specific for the React component. So it's specific. You might assign it to a div or to some sort of other element in the screen. Also, the state is specific to the model or to the dropdown. It doesn't really make sense to move it here unless you're building some more higher level hook, like more of an abstract hook that handles the whole notion of showing or hiding something positioned absolute on the screen. But in this case, we're going to leave the state here in the model and the ref. So we only copied the use effect. So we see this is depending on the ref. So that basically that's for sure that the ref needs to be a parameter. And we are also going to need, actually let's rename this to ref. And we're gonna need use effect from React. And now inside, I see that inside the handler here, I'm setting the state. So in here, I'm setting the state, but in the dropdown, it's something else. It's setting the state and also resetting the value in the select here. So this means that I have a custom function that needs to execute every time this click outside is registered. Hence, I'm going to use here a callback function. Let's call it just callback, and call it the moment when the click is registered. So now in the dropdown, I can remove this, and I can say use click outside. And notice now that this hook doesn't have a return type, because this hook just registers the behavior on top of the component. It doesn't compute a value necessarily. It doesn't expose some sort of state. It just adds this behavior on top of the component. And as a callback here, I'm going to say set is dropped false. And then we're going to go to the, this was the drop down. Oh yeah, I actually need to do something else here to make it fully correct. I also need to do set selected value. This was the code before. So it was resetting the value also when the click outside was happening. And in the model window, again, I remove this and I say use click outside. I pass in the model ref. And the callback now will just say set is open to false. Testing this, click outside, click outside. So you see, it's the same. Again, might be a very silly example, and probably it's something that you would implement from start like this. But just to show you that it's very easy to find behaviors, these kind of behaviors that are fully reusable across a different palette of components, if you want. Okay, so this actually reminded me, when I started noticing this pattern, it reminded me of something that React had a long time ago. And this is like this is an aside here for 2 minutes, but I just want to show this. Maybe it's something people find fascinating, or maybe they have fond memories or bad memories of it, who knows. So when React first appeared, this was the kind of composability pattern that was available in React. So this is syntax that doesn't work anymore, but you used to create these React components as calling this factory function, React class. And this had your lifecycle methods, your render function. So it's the same as a class component, but it also had this concept of mixins. And mixins were kind of something like objects that you would compose into this React component. So almost like doing object composition directly on this. And this was the actual problem. This is why there was this famous article by Dan Abramov that mixins are considered harmful, because with mixins you can very easily break the whole encapsulation of the component. You can affect anything that is on this, that is exposed on the instance, and it turned out to be quite a bad pattern in the end. But the concept of it was very good. It just didn't have the right tools to implement it. The idea of extracting these units of logic and state outside of the components and then mixing them up into components is actually very good. And this is where I realized that hooks are actually kind of built on this mindset, just with better tools and with, it's a safer implementation, if you want, of mixins. And finally, we get to something that I discovered even more recently, like close to 6 months ago, since joining Code Sandbox and working on one of the projects that I'll briefly show you. And this is the context. And what can you do now with custom hooks and with context? So just a quick reminder, context in React is, maybe it's not that known as a functionality, but it's basically a pattern called provider consumer, where a top level component would say, I'm exposing this value, this object, this string, this object with properties and functions, or like this state object, if you want. I'm exposing it in this entire sub hierarchy, and then any component can choose to consume that value, right? And has access to anything that the provider adds in the value there. So this is kind of a pattern of bypassing the need to pass things through props, right? You can have, you can pass something at the top level of your application. You're most likely using context, even if you don't know the concept itself, you're most likely using it with any kind of styling library that has some sort of theme provider, or with Redux, or with React router, or any kind. Pretty much any library in React has some sort of provider that starts the whole show, let's say. So what you do with with context now is that you have, remember this thing where you have now React components which are purely presentational, and you have your behaviors in custom hooks, and now you're adding slices of context. You can have one or many contexts in your application. Of course, you shouldn't necessarily abuse this, because it's not it shouldn't necessarily replace something like a proper state management library for a bigger project. But still, you can have things, you can have shared state across your application with a certain context that provides some values, but you don't consume that context directly into your components, right? You could use context for that, and then you have access to do that value. But rather, you can consume context inside these custom hooks. And by doing that, you basically create, you keep your logic, your interaction with the state in the custom hook. And then when you're consuming the hooks in the React components, you no longer need to have basically the logic in there. So this will make sense in a second, as I want to show you some examples on one of the libraries that I worked at. And this library is called Sandpack. It's an open source library. It's still in beta, and I can actually first show you the library a bit, and then we can jump into coding. But I want to show you how this pattern actually helped us a lot with the architecture of the whole thing. So you can imagine this. I can actually quickly show you what it is. It's basically bringing a very lightweight code editor as a React component into your project, and then you have an iframe on the right side here, which loads the bundler of Code Sandbox, and you can have these interactive code editors, right? Where you have some code snippets that actually run in the browser and give you the result of a React application that runs there, or Vue, or whatever. And these are React components that you can integrate into your project. And the way in which they are done is that we have components, but we also have the hooks. So you can imagine that instead of just exposing the components that make up this whole library, we also extract the behaviors from all of those components and expose them as hooks. And we will see in a second how you can use some of them. So you see these kind of hooks that have certain access patterns to the state of the library. Like, for example, the library, actually, let's go into coding and it will make more sense, I think, there. So I'm going to install Sandpack React. And let's see. Importing the library, and I need to import also the CSS here. Okay, so first of all, the library can be used as it is, as a single React component, and it gives you exactly this thing that you already saw. Some files that are available in a code editor with file tabs on top, so you can switch between them. You can change things and it will automatically re-render the whole thing. It has hot module reload. It's the same as running your example in Code Sandbox. You're just downloading everything into your browser and using the Code Sandbox bundler, which is also used here, by the way. So this is kind of like an inception case where we're using one and indeed the other. But what I wanted to say with what I wanted to show with this is more the composability of the library. So we didn't want just to have this component that you use and has like tons of props to it and you can configure everything. We actually want to give you, or we want to give everyone who wants to consume this library more flexibility to implement their own things and even to put their own UI on top of this behavior. So first of all, we implemented everything with the context. So we have a Sandpack provider, which is the top level thing here. And oh, I forgot to show you, you can pass in, even in the other component, you can pass in template like React. So because that was a vanilla template, that's why maybe it looked funky. I can show this quickly. So now it's a React application here. It's a create React app starter with hello world, and you can start editing it. And we're going to implement the same thing with the components that the library exposes. So it exposes something like Sandpack layout, Sandpack code editor, Sandpack preview. So inside the provider, I can say Sandpack layout, which is just that responsive layout that we have on top of the library, and then you have a Sandpack code editor and the Sandpack preview. And let's refresh this. Hopefully it works. Yeah. And the nice part is, again, I want to emphasize here the use of context. So context is really useful because sorry, actually, to backtrack a bit, we don't need a complex state management for this library. This is just, you know, a record of files, some dependencies that you can also add, some very small information like which tab is open by default, how many tabs you have open, if there are hidden files, stuff like that, but nothing too complex that you need something like, you know, Redux, MobX, or Overmind on it. So everything is handled inside the Sandpack provider. And then all the components that you use here internally consume with hooks, consume the values of this context. So like you can have two code editors if you want, and they actually have the same state. So like the value will be the same in both code editors because they are just consuming the same data source. So it's not like they're independent from this scenario. So yeah, this doesn't really make sense. But you have full control over the UI. So for example, you could say, okay, I want the preview on this side actually, and the code editor on that side. You can do that because there are no dependencies there are no restrictions of how you organize the components internally here. You can have another component that is something called Sandpack transpiled code, where you can see, hopefully it works. Yeah, but the layout is a bit hacky here. You can see the code, the transpiled code. So you can make like a REPL style of UI with this, where you have the code on one side and the transpiled code on the other side. Okay, and the best part with hooks is that I can also have something like, let's try to build a custom code editor here. React component that says something like this. I want to use active code. This is one of the hooks that we export. And this doesn't even have any parameters. It's strictly synced with the state from the provider. And it will give you the code, which is a string, like the code that you're visualizing at the moment, and the update code function. So at a very basic example, we can do something like, let's return a text area with the default value of code. Actually, let's put the value so it's controlled. And on change, we will call update code. And actually, I think I need, because this one can be undefined, and we are in TypeScript here. So it will be update code. And this is the event target value. Let's hack it like this. Not nice, but don't want to spend too much time on it. And now, actually, let's show this better. So now it's, let's put the preview in the back there. Now the code is actually in the text area. And when you change this, because it's connected to the state, it will just update everything. So like you can create a code editor with just that. Even more, like we can bring in, where is it? Let's try to bring in Monaco editor. Monaco editor is a very heavy code editor. That's why we don't have it in the library by default. So you can import it from this React library. And instead of the text area, you can say this. On change now gets the actual value of the code. And I can also say like language is JavaScript and theme is VS Code Dark, I think, maybe not. And height is, let's say 350 pixels. No, it's only VS Dark, yeah. So now what we have here is another code editor, which works again with the same things behind the scenes, on the same state it operates. And you can get any of these hooks, like use code sandbox link, which is the link that gets you a unique sandbox from this. Or you can say use error screen, which is then the content that you need to build your own error screen like this. Pretty much every capability of the library can be exposed. Its behavior, its logic can be exposed with custom hooks. And you can also get the components if you're happy with the UI. So yeah, I hope this does make sense in one way or another. Just one thing I also wanted to mention is that there are a couple of libraries out there that do this very nicely. So you can, it's not like a unique pattern or anything. We got heavy inspiration from things like React Aria, which is a design system. It's basically a set of hooks that allow you to implement accessible UI primitives for your design system. So they give you things like use, focus states, keyboard navigation, things like that. React Hook Form is another one, which gives you hooks for like all these form capabilities that you would normally have in your application. And also React Spring is, I found this a good example, even if it has, I think, a single hook, but like the hook is acting exactly the same. Like it gives you the behavior of the animation, and then you can build it in your own way with your own styling library or whatever you have there. So yeah, that was pretty much it. Sorry if I went a bit over time here. Like I said, I was a bit probably rusty from not giving a talk in the past 6 months, but yeah, let me know if you have any questions and I will paste this in the chat. And I will stop sharing my screen.
Oh, thank you, Alex. Thank you. It was a great presentation. I think with baby steps, everything, I really enjoyed it. There was a comment during your talk when you were talking about the imperative and declarative that ended up in the logic and view. And someone said, which is Angular now, don't precisely understand what the comment was about. But do you have anything in relation with Angular that you would like to say? And
not sure what I'm not sure what the comment is referring to specifically.
Okay. So don't see more questions. The Vue community is adopting this also. Here it is, Gabriel.
I get it now. So yeah, but one thing I didn't emphasize this correctly. So it's not. I guess in Angular you can also do this kind of UI interactions, behaviors into services, but I think services are mostly for data accessing and state management. So like for your business logic. Whereas in with hooks, in React, I think it's mostly about the kind of like the things I showed in the first part of the talk, right? Things like interactivity of the like what I call the UI state, whether you click somewhere and something else pops up, whether you show some spinner while this something else is happening asynchronously. So those kind of interactions.
Another question from Florin. Please provide a few examples in a Medium project where you would use context and where Redux to handle the app state.
So I think whether you're using Redux or any kind of state management library, to be honest, like I haven't used any of them in the past 2 years or so, but in any case, once your application is heavy on the business side, so like you're handling a lot of CRUD models, you're doing a lot of data manipulation, like showing tables, grids, stuff like that. That's kind of one of the signs where you need to strictly separate and keep stuff in like these separate maybe state management libraries. And then context, I guess for using context with that, I guess this is how you actually use Redux. You still consume it through the context, but the logic, again, it's different. The state management, the app state versus the UI state. The app state you would handle in Redux, whereas the UI state you can still handle in something like custom hooks. I'm not sure if that answered your question or not.
So Florin can put a comment there to see if it's clear for him. Another question from Nicola. Is it good practice to use custom hooks to connect to Redux store instead of the extra layer with the connect function?
Well, I think with I must say that I haven't used Redux in 3 years now, probably. So I don't know what are the practices now of how you actually connect to a Redux store. If the connect function is the same and you use it to do like a high order component on top of your React components, then I would say the biggest advantage of using something like hooks to connect to the Redux store is that you don't get those intermediate React components in your hierarchy. If you debug an application and you have a lot of those connect functions, you will actually get a lot of React component instances in the tree there, and it can get heavy on the computational side depending on the complexity of the project, and it can also get heavy just to debug stuff because you're getting lost in details. So I would go for using hooks because they have a much cleaner integration pattern with React components, in my opinion.
Nicola, you can react as a comment there. Thank you. So
you're welcome.
Felipe says, nice job first.
Thank you.
And then how can I identify when I should to use a custom hook? That was also my question. But
well, I would say I wouldn't go and do. Of course, as any question, it's like it depends answer is the best one. I wouldn't go with extracting every piece of logic from all the components, because that just is over engineering, and you will end up with just a lot of hooks that are used one time. I think as soon as you start seeing that, different UI components have similar interactions, like I just showed, clicking outside to close something. Maybe you have some sort of interactions of, I used to give these examples of infinite scroll lists, whether there's a list or whether there's a list of lines or a list of cards, but it still has this kind of infinite scroll behavior that it can reuse. Especially when you do a lot of event handling, global event handling, like document add event listener for scroll, for touch, for all of these, drag and drop. Now it maybe is another good example. So whenever the interaction is going beyond the very basic, button and on click set state, for that I wouldn't recommend extracting the logic away from the component.
How React is used by Radu? How React is used in gaming industry?
I have no idea. Like honestly, I don't follow the gaming industry and not a particularly huge fan of it. So,
but I'm sure Ken would love to give a.
Yeah, I would actually. Yeah.
Let's see. I heard that some games from Andrew. I heard that some games use React for their user interface. Well, not sure if Alex, you want to comment something on it, or?
Yeah, no, I don't. I don't know that much about that, but I guess since JavaScript can run everywhere these days, yeah, I'm pretty sure that you'll find React there.
Yeah, good. Moving the community further and humble, Alex. Really like that. So modest. Maybe if there are not any more questions for Alex. Alex, if you could stay with us while Ken will continue, it would be great.
Sure.
I think there are many angles from where Ken can shift the conversation. Maybe he could also answer to some of the. Oh, here's one. How could we manage forward ref? That would be the last question. Last one.
I'm not sure what do you expect by what do you mean by how to manage it. I think so. Forward ref is used mostly for exposing the ref of a primitive element outside of the component. For example, if you're building your custom button component, you're exposing the ref of the actual HTML button that you want to render there. I'm not sure what you mean by managing it, but like feel free to drop a message privately in here and we can continue the conversation.
Thank you, Alex. Now we will go to Ken Wheeler. Ken, if you could.
Okay. Hey, is my video not working?
Not.
Classic. Hold on, let me plug it and unplug it.
Ken, while you do that, thank you for being with us. I've looked to many of your videos, and hopefully the people who attend today also watched some of your great talks, listening to music in the browser, WebAssembly, performance. I really enjoyed them. I can see you, Ken.
All right, we're in business. Thanks. That's awesome. Yeah, it's always a fun time.
So what are you going to talk about today?
I'm going to talk about runtime performance.
Oh.
Yeah.
Okay.
I mean, I'm not really making any music in the browser or anything, but it should be helpful.
But it's fun. And I know you like to do things fun.
Sure.
Okay, Ken, floor is yours.
Okay. Yeah. So what do I like share my screen or something here? You get a keynote going, I guess. So you could see this, right? Can you see this?
Yes.
All right. All right. So my talk is called Doing the Least Amount of Work Possible. And that's an intro to runtime performance. That's what I'm here to talk about today. So what in the world is runtime performance? Some of you probably know. Actually, all of you probably know, but it's important to distinguish against load time performance, right? So most of the time, when people are talking about page performance, or folks from Google are yelling at you on the internet or what have you, it's load time performance that everyone's up in arms about. And you'll see these things like like Lighthouse scores getting posted, and when you're trying to measure that, right, you're looking at a couple different things like Lighthouse, Core Web Vitals. People are concerned with bundle size and how long it takes to parse that much JavaScript. Then you have metrics like first contentful paint, FCP, or TTI, time to interactive. And I don't want to sit here and minimize the value of those things, because it's important, particularly if you have a website or a web app in like commerce, right? Because those things can be crucial, right, to retaining a customer, to driving conversion, right? The faster the page loads up, in between your pages, right, the people aren't going to leave, and it's generally pleasant in a good way. There's a billion reasons why it's something that you'd want to do, but a lot of the time what'll happen is either you'll get your load time perf and then all set, or you have an app where runtime performance is actually more important. There's certain web properties where it's like they're not gonna leave, right? That you kind of have to use it, or you're not buying it and you're not converting. It's just an app that you're using. So after the load, or if it's staying up or whatever, it's important that it continues to be interactive, right? So runtime performance is about once you've gotten interactive, you have time to interactive, it's staying interactive, keeping the application experience pleasant, right? And what that largely consists of is not blocking the main thread. If you have a site that's not interactive, I'd say 10 times out of 10, your main thread is blocked, right? So what'll do that, right? What are some typical runtime performance issues that you might run into? One is computationally expensive tasks, right? If you try and do something really rowdy, that can do it. Things like animations and graphics updates can also be particularly rowdy. It can muddy up your availability there. Shockingly, well, maybe not shockingly, but you think like doing AI in the browser is what's going to mess it up, but a lot of the time it can actually be a side effect of CSS or CSS animation, and that's when you see things like reflow, repaint, and layout. So yeah, I'll hop into it right now. So basically, like when you have a web browser, it's really just a big canvas, right? So they use a graphics library called Skia to actually draw it all out. So when you have a thing like reflow, right, that's essentially invalidated a section of the page that it now needs to redraw. Same thing with repaint and layout, right? If you move something and other things derive their position from the position of that thing, now you need to recalculate all the positions of the things from which that position derived. And that's expensive, especially with more elements on the page. Another thing is parsing, right? So if you're like if you have a lot of data coming in over a WebSocket or something like that, or you're trying to load up a a file or a buffer or whatever you're trying to do, a lot of time parsing that into, a workable thing like JSON, that can block you out pretty good. And the last one is the worst one, which is memory leaks. And that's when, you'll sit there and you'll get on an app and you're having fun, you're having a good time, it's running smooth, and then like half an hour later, everything's grinding to a halt and you get frog in the potted, right? It was like a little annoying 15 minutes ago, but you're like, and now it's completely unusable. And that's one of the worst ones because as a developer, right, you have to sit there and wait for 30 minutes to verify that it was fixed. So it's extraordinarily time consuming to fix a memory leak if you don't know where it's coming from. So how do you know that you have a performance issue, right? This is something you want to look into. Your best case scenario, right, where it's not too bad, is you have some dropped frames in your profiler, or you have something like input delay, like you go to type into a text box and it's not really matching up with your fingers. Worst case scenario, right, which is the worst, is the aw snap, right? Sometimes it'll just crash it completely out. And then that's hard to debug, something that instantly crashes. Not fun, right? So how do we fix these things once we identify that they're happening? I could tell you, a couple things, right? But the funny thing and the fun thing about performance is that it's not prescriptive. There's some guidelines, but generally speaking, a performance problem is a very personal issue where it's pretty unique to your implementation a lot of the time, and you have to figure out where it's coming from. It requires detective work, and then sometimes it's not even a bug or bad code. It's just a reality of the requirements, and in order to achieve like the performance level that you're necessarily looking for, sometimes you have to get clever. Sometimes you have to do tricks, right? If you have to load 500,000 things into a container, right? You can't say we can't load 500,000 things if your job is to load 500,000 things. You have to say, okay, well, how can we make it look like we're loading 500,000 things, and then take it from there, right? So as far as the prescriptive things that I can tell you to generally apply, right, if you're having issues, here are a couple things, right? So first off, anytime you have any iteration in play, anything on a timer, anything on a loop, anytime you're iterating through things, right, those are your hotbeds of shenanigans. Looking in, so first of all, you want to have less iterations, period, right? So the less you're looping over things, the better. But if you are going to loop over things, it depends on the scale of your problem, right? If it's not that big of a deal, right, using a regular for loop isn't going to be that big of a deal. But if you're operating at real scale and speed, then switching to a for loop will actually have a measurable difference because it's that much faster. Other times, like instead of like searching through large arrays, like if you have a large array, rather than doing like a prototype find on it or something like that, you can use a lookup table, right? Which is when you're actually initially populating that array. You can go through and create an object, right, with a key that points at the index, or however you want to do it, but it allows for non-iterative access to any given index. A big one is not creating new objects. Not only is it expensive and takes time, but what you'll see is the garbage collector will go bananas, and that'll really take time and jank everything out. One thing that is less math sciencey and more people sciencey is perceived performance, right? So a lot of the time you can make things faster without actually making them chronologically faster. It's just that people think that it's faster, right? So turning off animation is a big one. If you have a site where you have a lot of like fading hovers and things like that, and you turn off the animation, right, they're going to immediately think that that's faster, right? Because they're getting instant feedback to their user interaction. And there's a lot of things like that where you're going to see that nothing is necessarily actually faster, but it tricks your brain into thinking it's faster, and that's a fun and easy way to do that. Another thing is to avoid reflows and layouts. And I could show a little bit more about that in a little bit. Caching, everyone's favorite thing in the whole entire world. Whoop, hold on. I was clicking zoom and it, dang it. I can't click it again. I gotta go back. Yeah. All right. So caching, right? Yeah, and that's really things like if you don't have to call something twice, don't call it twice. I had an issue where you know, I was getting destroyed by creating date objects, and we were converting a number to a date. And I said, you know, rather than every time we get these things, converting the dates, right? As we get them, let's cache, you know, for that number, the resulting date object, and then you know, serve that back instead, right? And then eventually your dates are cached, and then you're kind of just serving out of the cache, rather than actually creating new dates, which is very expensive. And then, you know, when you really want to get into like micro optimization, right? There's sneaky minutia that you can, you know, things like bitwise operators, or using you could set an object index to undefined instead of using the delete keyword to delete it, and that's faster. But it's important to note that for every performance win you get, almost every single time it comes with a equal trade-off, right? I forget what the exact thing with the undefined is. Maybe it's still available when you're iterating through it or something like that, like a has own property or keys thing or something like that. But you know, nothing is a clean win. A lot of the time you're doing trade-offs, right? Like if you're doing virtualization, which is where you only actually put the things that are visible into the DOM as a list, right? Like you can't do like Control F find on it, that kind of thing. So yeah, I mean, it's weighing, you know, is this being faster more important than, you know, being able to do find on it, or we're gonna, yeah. So that's all considerations. But the most important thing you can do to improve performance is profiling, right? And that is, you know, collecting metrics on how the site is running, going and working some magic, and then running it again, and then you can analyze your results. And it's also fun because, you know, you can report back, say, I've profiled, I've made some optimizations, and now it is 25% faster, and it sounds fun. And you know, you know how much faster it is, so now you have your initial benchmark to start with, and then this is what you've done, right? So some things that we can do to get those profiles or metrics, right, are things like the Chrome DevTools Performance tab, where it'll record all the things that are going on, and then it'll show you on a timeline, you know, what was happening, and that's helpful from solving bugs in general. You know, if you don't know what's you know, if a thing's having a problem looping out or something like that. But as far as regular performance, right, you can really see what's going on. The memory tab, right? So if you have memory leaks, right, you can take these snapshots, and then you can compare the two. You could say, like, over this period of 5 minutes, you know, and then sort by count and see what was being allocated, and then you'll have a better idea of you know, how that memory leak is accruing. Also, the performance monitor is helpful, right? If you want a real-time view, and I'll show that in a little bit, of what is going on your site, right? So that's less recording, that's more real-time, and you can actually see it and watch it jump with certain interactions. One of my favorite things in the whole entire world is the the user timings API, right? So if you've used React in dev mode and you've done a performance profile before, you'll see like it has like the little React nuclear emoji next to some yellow stuff that shows like how long the components take to render. And what that is user timings. It lets you define marks and measures that show up in the performance tab profile flame graph. If you're using React, the React profiler is outstanding. And what that lets you do is you can hit record, you can do some things in your app, and then you can look and you can see how many times certain things rendered. And oftentimes it'll tell you why they re-rendered, which is crucial for reducing the number of renders. If you have a problem with a React app, chances are you are over rendering. Things are re-rendering more often than they need to be. And that's a great way to get to the bottom of it. Last but not least, which is like elite hacker mode, is Chrome tracing. And that's sort of like the performance tab flame graph, except for the actual underlying processes in Chrome. You probably won't go in there, but if you do, you can really see what's going on as far as certain performance issues and how the browser is actually handling it. If you're in there, you're generally in trouble. Yeah, so let's learn how to use some dev tools here. All right. So I got some, I'm just gonna get this chat out of the way, some of this stuff. All right. So say we have a straight up React app. This already has a performance problem, but you'd never necessarily know because the animation takes place elsewhere, right? So here, I create a list of objects, or an array of just objects with an ID and a value, random value. Then in our app here, right, we don't actually render any of that, but on a half-second interval, wait, hold on. Gotta put a qualifier in there. This is just gonna be bananas. Yeah, so on a half-second interval, what it'll do is go through the list, and here's a key point here. We're gonna make a copy of the list, right, by destructuring it here with the spread, or maybe it's not a destructure, it's just a spread, and then iterate through it and set a new value with math random, and then return it and set state. So there's two things here that are particularly rowdy performance wise, and that's the list cloning with a large list, 100,000 things, and also React state itself. Anytime you're setting state, that's like super expensive, generally speaking. So you know, a lot of the time what I'll do is if you know, there's like the prevailing thing like, oh, just throw everything in state. Don't throw everything in state. You know, if it has like a bearing on, you know, things that are going to change in the UI, sure. You know, if you need that to trigger side effects, sure. But you know, like if you're going to build like a lookup table or something like that, or like some like index that you can just look up, you could just use a ref, right? And use ref in React now is, you know, the equivalent of like putting this instance variables on a class. That's where you would like store like event listeners back in the day. But yeah, this, you know, putting everything in state is for silly geese, in my opinion. So yeah, this app has a performance problem that you might not know. So let's actually take a look at the performance problem that this app has. And we're going to learn how to use DevTools. So this is your Chrome DevTools, the performance tab. I hit record and we profiled for 7 seconds. Now it's processing. Yowza. So, I mean, it's really not that bad of a performance. I probably have to jack it up a little bit higher. I don't, you know, the frames are, and it's still 60 frames per second. So that's all right. It was a little CPU high. Let's jack this up so we can see some real indicators of shenanigans. And I'll refresh her. Now we're talking business. So one thing that's a problem, right? If we look at this performance monitor that we were talking about earlier, here you could see CPU usage is at like a steady 30% here, and that's that list cloning stuff going on in the background. You could see your JS heap going up and down, right? GC is getting the job done. DOM nodes, event listeners, right? Those are steady. If event listeners were increasing, right, then you're not tearing those down in effect. And that's like one of the most common memory leaks. But let's take a look up here. So if you see this little red corner tab business, bad news. And you can see in this flame graph when you zoom out, come on you. Right here, it'll say like you have like system, scripting, rendering, painting. So the scripting is the yellow, and that'll let you know where this is deriving from. So here you can see up top these little red block regions, right? This is when it's blocking the main thread and it's not interactive. And we can come down into here and just follow the stack all the way down, right? So you have timer fired, function call, anonymous. You can look over here and see what this is, right? It's app.js 18, go into sources. Over here, right, it'll sit here and you can see these particular metrics for how long this stuff's taking, which is pretty wild. Head back over here. And then you see this garbage collection going bananas, right? And yeah, really you just trace it all the way down, right? And it's not just, so here we have, this is your main thread, but you also have your GPU, your compositor. The compositor's having fun because we're doing a little animation here with that React thing. But yeah, you can see this going absolutely nuts here. And I'm gonna show you something cool. So
Ken?
right, yeah.
We have a question from the audience, and you said to shoot directly, huh? So sorry for interrupting.
Yeah, please.
Andrew said, when should we use React use Memo and React Memo? Should we use them always?
The React Memo is kind of like pure component in the sense that you don't get it for free, right? There still is a shallow quality comparison taking place on previous and current props, or current and next props. So a lot of the time, like my ideology around that is, if you have a component that renders 2,000 components underneath it, it makes sense to put it on the parent component, but it doesn't on the 2,000 components underneath, right? Like you can use them to gate off certain sections from rendering, but if you just put it everywhere, then it's going to be really expensive to do all those checks the whole time. As far as use Memo, I use that when I don't want something to be new, right? So I'll use Memo if like a lot of the time, like I'll create like an object or something like that that's new based upon some prop or state or what have you. But like if you have like a hook dependency, if you're creating a new one each time, then that hook always fires. Whereas like if you want that to be the same value, so the hook will only run when it changes, then you can use Memo to ensure that it's basically the same shit each time. So I'm just going to run in real quick here, and I just want to show the user timings API. So I can say here, I could say like, how did that go? So you'd say like performance dot mark, right? We could say like 1, and then here we could say like performance dot mark 2, and then you're giving them names. So here I could say performance dot measure right? And then let's call it like a clone list, right? And then it's the start mark and the end mark. So you would say 1 and 2 like that. And now if this is running, when I go and I run a performance profile on this, you're going to see this user timings thing right here. And then I can come in and you can actually see this, right? Your clone list isolated, right? So if you want to have like labeled specific things in here, that the user timing is a great way to do that. And you can dev flag those and stuff like that. Right. So one of the last things I want to show here today is I'm actually going to get rid of all this shenanigans here. And oh, hold on now. Went 2 bananas. And I'm actually I'm gonna screw our performance up with CSS real quick. So here, right, I could say like height is or yeah, no, I'm not gonna do that. I'm gonna say let's say height is like 200 pixels, and then we're gonna go height to like 400 pixels or something like that, right? Because height is one of these things that you should not animate because it actually triggers layout and repaint. So see this right here? Do you see this? I don't know about the fidelity of the video cast, but this thing is just doing the jitterbug, right? And we'll find out why in a second. So when I come here and I do a little bit of profiling, right, we can actually go in and write, wow, look at that. This thing is having too much fun. Yeah, so you can see like we're dropping frames all over the place. And before, right, remember we had a lot of yellow, right, because that was scripting, that was JavaScript fucking everything up. Here, the rendering and the painting, right, the layout caused by, animating the height of something that's, causing these repaints, that's actually what's destroying your performance. So you don't need JavaScript at all to destroy your performance. You can do a good job of that all on your own just with CSS alone. I think that the rule is, transform and opacity is what you can rock with. Transform because it does compositing, and opacity because it's not necessarily moving or changing the dimensions to trigger a layout or anything like that or repaint. So yeah, that's my talk. I hope that everybody learned something about dev tools that they didn't know today. And if you have some slow apps, go make them fast and be the hero. Thanks, everybody.
Thank you, Ken. Now, everyone, please feel free to ask your questions here. Before that, I have some questions for you, Ken. There was a previous question about React and the game community. If you could give some hints about that.
Say that one more time. The React game kit
and React in the gaming industry. If you can say something about that.
So I know that it's definitely used in definitely in some of the UI, like when you take the actual games aside, right? Like some of the UI of the systems is actually in React. I want to say PlayStation actually uses React a fair amount. But yeah, there's definitely some React in play, and I've done it before just with the DOM. But you can do it with Canvas. In React Native, I don't really know the status of it, but I know that I've done it before. It's absolutely possible to bridge those type of things. You look at something like React 3, and you can do some really impressive stuff with that. I know that Expo has Expo GL, which I believe uses React 3 in some capacity. But yeah, I've seen some really cool games built with and these are like native phone games running GL on the system natively, not like, React Unity, written in React. I personally, I mean, I've used Expo.gl, but I haven't done like that many browsers. I think the last game I wrote it in SpriteKit for shits and giggles.
Okay, see some useful links there. And I have a question about the, for example, CSS Transform. Did you discover this through trial and error, or is there a specific resource where you look every time and you study them and you learn a lot in terms of best practices?
I probably read it somewhere. I believe I saw it as like a general tip. I think it was the first time I think I saw that. I believe it was an article from Paul Irish, maybe. I think.
Okay.
Yeah, I mean it's been like a prescriptive piece of performance advice for a little while now. And yeah, I mean it's like I've had to do a lot of UI programming, and it's become clear how important that is. I can maybe like the first time you hear it, you're like, but like then you have like some problems and you're like, oh damn, maybe they're right, and then you start to realize like why it's actually that way, right? And it's because of the composite and paint and stuff like that. When I first did, I just took it at face value. I'm like, all right, transform and opacity it is. But now I understand that it's about like if you do a translate on something, say you have 3 blocks, right? 3 like 200 by 200 like red pixel squares on a screen. If you do a translate X on that, right? It's like you pulled it up and slid it over, right? And the 2 things on the side of there, even if they're flex, right? They're not going to like go into the negative area, right? Like if this one goes up, this one's not going to slide over if it's float left. And the reason being is that the actual layout for that thing is still there. It's just composited up. So it takes it on a new layer and moves it up, right? So what you're doing is you're not forcing layout.
Let me look again at the questions. I see there are some very useful comments here as well. Some resources from Alex, CSS triggers. Question from Mihai Marta. When should we start thinking about performance optimization when developing React apps?
I try and keep it in the back of my mind, but it's not like I'm like optimizing super early on, like my most important thing is getting to the finish line, or at least getting to the show people line, right? So it's like, hey, check this out, right? And then if we have to go back and make it faster, I'm happy to do that. The back of the mind thing is just keeping it in mind so you don't architect your way out of the ability to refactor it later. Like adding like a lookup table where you're doing an array find is pretty straightforward. But if you're not using virtualization from the get-go, then that's a little bit tougher to retrofit using something like React Window or something like that, right? And then you have to go back and deal with a unique set of challenges related to that. So a lot of it's like anticipate, like if you have like a drop down menu, like a select kind of menu thing, but you're using a custom one, the normal one uses the platform one, which is already optimized. But if you have a custom one, right, if you fill that up with like 2000 LIs, right, it's going to take a shit ton of time for it to actually open, right? So like you need to say like, am I in a scenario where there could be 2000 things in this? And if there is, right, do it virtualized from the get-go.
So Mihai, you can put a comment there when if that isn't clear enough for you. So thank you. And Radu, question for Radu now. Are you skeptical about web GPU, or what do you think about it?
This is the first I'm hearing about this, and it sounds pretty cool. Yeah, so it's GPU for the web, so it's like a metal for the internet. Yeah. So I'm really not smart enough for shaders, right? So I'd be more excited about it when somebody builds like a thing on top of it, right? So, like I think it's great. Like Metal's super fast, and that'll probably make things. WebGL is pretty fast in the first place. I think that as far as making it accessible to everyone, it would be abstracting it into, it needs its own 3JS, right? Like I have difficult, yeah, Pixie. If it had its own 3 or Pixie, right, where you can code it in people language, that helps. I'm not smart enough for shaders, so.
But until the next question, you had some interesting projects that you committed to the React community, React Music, GameKit, Webpack dashboard. Which one is the most successful in terms of adoption, Ken?
I mean, well, most of that stuff was toys, right? So I think probably like Spectacle or Webpack dashboard or Urkel. Definitely Urkel. Urkel is first class nowadays, and that's because I'm not writing it. The good folks at Formidable, like Phil, are leading that project now, and Urkel is amazing. I liked Urkel back then, but Urkel is crazy now. It's so good. So Urkel is probably definitely by far the most successful. If we're talking about stars as a metric, I think that behind Urkel is probably Webpack dashboard. That offered some pretty helpful visualizations. I saw there's a question: how do we use request animation frame for better performance? And it would, I mean, anytime you're gonna do like an animation style thing, like you're gonna make like an animation type change, throw it in a request animation frame, right? Because then it'll schedule it to start at the front of a frame rather than throwing it in randomly, which can make you overlap your frame. If you're doing like canvas, you can do a loop on request animation frame and then kind of just like draw at the beginning, and that'll keep everything interactive and nice.
Let's take 2 more questions from the, and Alex, if you could also join us to conclude and see how both of you felt about it afterwards. Let's see. Seems there are no other questions. So Ken was talking before that. So what are your thoughts on federated modules in Webpack 5?
Me?
Yes, Ken.
Oh, yeah, I think they're cool. I haven't gotten to put them in prod. So I can't really speak to it like that, but I love the idea.
Okay. I think that should be it with the questions. Hope everyone enjoyed it. Now, please, Ken, because you were talking before, and I will ask Alex, how did you feel during PentaBAR? How was it as you expected?
It was great. I think it was fun to talk to everybody. Having the chat thing was fun and interacting with folks. How I felt personally, very comfortable because of this performance polo. It's literally summertime on your body. So I felt very comfortable. It's about 75 degrees in this room.
Alex?
Yeah, it's not that warm here. So yeah, I think it was really nice. I really enjoyed the conversation and the questions. I think it's just I still find it awkward to talk in front of the laptop and not be able to see like the faces of people. I'm like, like what is he talking about? So I really miss that. But yeah, it was nice.
It's so weird when you don't know if your jokes land or not. Like you tell a joke and then it's just like, and you're like, I don't know. were they laughing at home?
So, I drank coffee during the JavaScript doesn't really work with coffee that well, right? So, are you on coffee during this talk?
Mm-hmm. Yeah. Yeah. I right before my talk, I had my 6th cup of coffee for the day. And it is 11 a.m. here. So there's still a couple to go. Right around 5 p.m. is where we switch to brown liquor. And then maybe tequila. We'll see.
That's when
Alex?
the real work starts, right after 5 p.m.
And one last thing, did you meet before, you two, Alex and Ken? Did you?
Oh yeah.
Yeah. I think we met in London,
correctly,
actually.
the last time we were hanging out was that London,
Yeah.
and we got a doner kebab, did we not?
Yeah.
Good times.
Yeah, London pub crawling after a conference.
Wow.
Yeah.
Man, those are the days, huh?
It's just a matter of time. Just a matter of time. Everything will come back to the normal, even if it's a new normal. Alex, Ken, I really enjoyed being here with you. If you have one last thought for the community, for those who hear us, each one of you, please share. I will ask Alex before and Ken at the last one. Alex, one last thought?
Yeah, I don't know. I'm not that good at improvising motivational stuff, but yeah, I just wish everyone good health during these times, and keep being curious about learning new things, doing new stuff. Keep that flame going, and hopefully soon we will be able to kick off actual meetups and face-to-face events, and that will be a load of fun.
Beautiful. Ken?
Oh, yeah, I guess I would say that as things are shifting back towards normal, close the fucking computer and go enjoy the summer. I mean, you can code a little bit, right? But get out there. It's a nice world out there. Go a little wild.
Very motivational, I'd say.
Yeah.
For my colleagues that watch this, hope everyone will come tomorrow at work as well. It's good to follow Ken's advice. Let's take holidays together.
Beverages.
Thank you. Thank you, everyone. And see you at the next PentaBAR. Bye.
See ya. Bye.